Hello, this is Jouke. I'm the host and founder of the European Software as a Medical Device Meetup group. This is a recording from our session on May 17th, 2023. It's the 15th meetup, which I'm pretty proud of. Nice milestone. The topic this time was the Software of Unknown Provenance, as mandated by the IEC 60304 standard. We had a long discussion in this session about the pros and cons of managing software by external parties, how to do it effectively, and how to prevent spaghetti code in your code. It was fun. This time, I'm happy to say that we are sponsored by MedEnvoy, which allows us to record these videos properly, put them on YouTube, those kind of things. So thank you guys. Awesome. I'm very happy with it. The recording is very nice, and I hope you will learn something from it. But you're missing out on a couple of things that are happening in the meetups themselves. That's a chance to network with other people, peers, experts, whatever you want. We have breakout rooms for about 20 minutes every meetup where you can just talk to people about your issues with software as a medical device, and you can learn and make new friends in this space. So there's also a Q&A section, which sometimes is recorded and sometimes not recorded. We like it a lot if people join in person and not just watch the videos. I think it's a good chance for you to meet and network within this community. So I hope to see you next time, which will be in end of June 28, 2023. And for now, I hope you enjoy this video.
So, welcome everybody. We are a cozy group today, I see, with 17. The first household note is that this meeting is being recorded. So we will keep a copy internally and then publish parts of YouTube's. And if your face shows up in the video, we will ask you if we can publish it before we will ask you specifically if your face is in the video. We will ask you if we can publish it on YouTube. So we hope that you're okay with it, and if you're not, send us a message. And then let's go to the next slide. So welcome. We started this group. Jouke started originally. I joined, I think, about 9 meetups ago now, and we see an increasing question for e-health and software as a medical devices. We are looking at increasing problems in hospitals, in healthcare, and of course with the COVID pandemic, we saw a lot of a shift towards digitalization, and SaMDs and e-health is the absolute biggest potential technology that can make a difference in this. So we have this huge potential. Artificial intelligence can do a lot of things better than people can. We have an aging population, so the demand for healthcare will skyrocket, and we have then like this huge opportunity, but also a huge hurdle. And the hurdle is in regulatory, and whether things are whether knowledge is openly available, openly shared or not. Often this knowledge is kept behind doors because it's the property of consultants and they don't want to give it away for free, or they it's from a company themselves, and the employees have under contract that everything they produce for the company, that it's property of the company. So the knowledge is often behind locked doors, and we really wanted to open those doors and share knowledge freely, and to build a community to be able to do that. So I think that is the goal of this group. Also, to build a network of industry experts willing to help each other. And we also highly recommend to join the OpenRegulatory Slack group to discuss best practices, ask all your questions. I know for certain it helped me out a couple of times. So yeah, we really recommend that. And let's keep the knowledge sharing open. And one thing that we need for that is to have some active participation. Today we are with 19 right now, so I don't think that it will be the scariest place to start sharing. And we just each voice that adds to the conversation we highly enjoy. So yeah, thank you so much for your input.
Okay, so next is my part. I have a couple of interesting announcements today. So first is that we are very proudly sponsored by MedEnvoy. We'll tell you a bit more about MedEnvoy later. Emma works there, and now they are also sponsoring this meetup, not only in Emma's time, but also financially, which leads us to the next topic. We have a YouTube channel now where we record videos and post them afterwards. I was doubting for a long time whether or not to do this, but I think we saw that a lot of information is just valuable for a longer time, so it should not be kept in one evening. The downside is I think that people have less of a need to be here physically, so there will be a bit less participation maybe in the evenings. We'll see how it goes. We're trying to find the best combination there. Maybe one of the coolest things is the breakout rooms where you can network and talk about your questions in a small group. That's of course not on YouTube, but that's the exclusive part here. The other one is that we are looking for people, for speakers and panelists every time. And to be honest, this is a real struggle for us right now. So I came up with a plan. Like I try to experiment something every single meetup. I think people don't volunteer themselves because they're shy or they think they're not experts, whatever. Or they think, oh, they'll figure someone else out. So I think we introduce a middleman. We're looking for talent scouts. So I have one talent scout already, Marley from my work, and I'm looking for 3 more talent scouts. So if you want to help find the next people for as a speaker or panelist, please let me know. If you have a big network in regulatory or quality, then please let me know, and I will add you to the list of talent scouts. And then the idea is that for the next couple of meetups, like 3 or 4 or so, you help find people that are willing to be a speaker. So you can send me a message right now if you're already interested, and else I will keep on spamming you via the Meetup channel. Last one is that we are creating I am creating a sister Meetup group for leaders in software engineering. Basically the same recipe, but a different topic. It's about managing software teams, and it's mostly for people in the Netherlands. Then the agenda for this meetup. We are doing the introduction right now. Oliver will give some updates, like he always does, about the community and also regulatory updates. Then we go into the breakout sessions where you can network in a small group of 4 or 5 people. Then Pascal will do a showcase and answer some questions from the audience. Then we have a short break, and then we have a big panel discussions with 5 prepared questions, and then time for questions that you have in that moment. That's it. So maybe first, this should be first next time, I don't know. But I'm Jouke. I'm Jouke Waalesson. I'm the CTO at Easy right now. I have a lot of software experience, and oh, that's a good suggestion, Vincent. I have a lot of software experience, and quality regulatory was very new to me in this position, but we are a medical device, so I had to learn it the hard way. And after I learned it the hard way, I thought, okay, we should make it easy, and I started this group. And after a couple of years, I found Emma, and Emma said, hey, I would like to join, and she's now the co-host. Emma, can you also tell something about yourself?
So I have currently 3 years of regulatory experience, and I started as a CTO-ish position at a very young startup with only 2 people for a class 1, very non-active, non-software device. And after 6 months, the company did not have enough money for me anymore. So then I moved on to software as a medical device company. And that is where this interest has come from. And for this company, I asked them, so before I did my job interview, hey guys, so what do you know about your CE marking? What are you gonna do with it? And they looked at me with big eyes and they were like, you tell me. So I think that really clearly showed me that it's so hard. There is such a barrier, and that is really why I really love to join hosting these meetups. And you will hear about my current employer, Madame Voy, right now.
Awesome. So MedEnvoy is a global sponsor. We created a beautiful global a gold sponsorship package for them, and they are an authorized representative to bring your medical devices to either medical devices or IVDs into the European Union, UK, or Switzerland, and we help manufacturers maintain control over their products while you ensure regulatory compliance. They have a lot of people like Emma, fantastic people that know a lot about quality and regulatory. And we, as Easy, are also a customer. Easy, we are an online eye exam based in Amsterdam, and we are currently still MDD Class 1M, and we're still waiting for the results of our technical file review for our MDR submission. So still, this was the same, I think, for the last 2 meetups. Next month, we hope to be MDR Class 2A certified. All right. We have a couple of presenters and panelists today. So Pascal, the panel is Stefan, Oliver, and Ivo. And I think we have a solid backbone of people that are always willing to help. So ideally, we're looking for more outsiders or that are new or that typically don't really share for the panelists. But we have a solid backbone of the hardcore group. And Oliver and Ivo are very happy to help today. So thank you, guys. And definitely also Pascal and Stefan. We're looking forward to hearing you speak.
Yeah, so maybe some words on myself first. So working in regulatory or medical device regulatory since around 2015, 2016 in the beginning as a founder and a software developer, and then towards the end more and more regulatory, and then 2019 doing full-time freelance consulting on medical device regulatory for startups, mostly software as a medical device and digital therapeutics or digital health apps, and yeah, doing that since 2019 now. And yes, so when preparing for this presentation, I was wondering, like, what is it worth talking about without just presenting like one potential approach that may only work for one specific setup. And so I was going through the different projects I've been working on, and also like looking at the recent publications by FDA, which has like that kind of has added cybersecurity and specifically SOUP like to their kind of reasons to refuse medical device applications now. So that was relevant, but then in plenty of other regulations and laws and so on and norms, it's a bit of a bigger topic. So what I was trying to do is more like giving some kind of a framework or mental model of how to approach it. And then for specific cases, I think there's more time afterwards where we then can discuss like what is the least I can get away with without like having to pull back my device, for example. I mean, happy to discuss it, but that's not necessarily the focus of the presentation. So next, first of all, what is that? So what does IEC 62304 say? Like the first, it's about basically off-the-shelf software. So just any random software that you may take and think it's good to be used within a medical device. Typically something that's not incorporated into the software itself, for example, but used as like a kind of a database. So you probably don't write the database yourself, but you just take one and run that as a service in parallel to your algorithms or like the backend itself. And then the second, anything that was not developed according to medical device processes. I mean, similar for the first. So basically, soup is like, on the one hand, libraries that you have either developed internally, not according to medical device processes, or have taken them externally, or on the other hand, any kind of software that you may still configure, but but more like use as a whole, like a database as that. Then yeah, what are goals of soup management? I kind of took that as a question from the discussion later as well. But it's always good to keep that in mind. I mean, the first is obviously like performance and safety. Like you want your device to do what it's supposed to be doing. But then also, yeah, whenever you think like, yeah, IC 62304 does not require me to do this and that, then the next topic would be data privacy or GDPR. I mean, like even if your device can't kill someone, there may still be personal data and you don't want them to leak. So, and the third would be correct licensing. Like, are you allowed to use a library the way you're using it and so on? So like there are kind of three different ones. And then the fourth point here, IT security, I mean, it's relevant for number 1 and 2. Like, I mean, even if your device generally works well, I mean, if a hacker can still get in your system and fiddle around with the algorithm, it may not work as it's intended to. Same for data privacy, but that probably needs less context. So yeah, what is included in soup? So I think also a question for later as well. So to come back to the turtles all the way down or up. So just like showing like here with an example of backend system, like what you may typically have in your stack. I mean, when you start on a bare metal server, you have hardware, then maybe virtual machine on top, then an operating system, then maybe some container environment like Docker. On top of that, maybe a runtime environment, and on top of that, your application like with the libraries that you use. But then when then you may add to that some other containers like the database that you have. Then you probably have other software on that machine as well. And you may even have some hardware next to it, like some hardware encryption module or so. So it's like a fairly complex system, even if it's just some Node.js application that runs on some server. And then obviously, like if you then use like a container as a service, something, then you just don't see all the turtles, but they still exist. But you basically need to know your runtime environment that you use or manage. So yeah, traditionally, and say traditionally more from a digital health app perspective, I mean, there's surely all kinds of medical devices, but that's more like the experience that I have. So basically whatever is marked red, so we're probably not surprised why they have a different color, like is what you may consider as soup. So like the kind of databases as talked about earlier, as well as like the libraries that you include, as well as like the Python. So it's basically I mean, I realized deployables is actually not a word in the English language, but still using it from time to time. So basically all the Docker images or other packages that you have that you ship your device in or deploy your device in. So basically whatever you produce and hand out or take from somewhere else like a database and hand out with your device, that should be covered as or should be considered as one form of soup or the other. But then looking at the rest, I mean, there's a whole more of a stack around here. I have to switch over. So, I mean, can you just ignore that? So basically you take proper care of your application, the database and Python, but then it runs on a Windows 95 from 100 years ago. Probably not a good idea. So I guess that question answered itself. But then looking at like, even though it may not seem like a good idea, like where does it actually come from? Like, why should you be doing that? And it feels like whenever you're looking for like an answer like that, the GSPRs are not necessarily the worst answer. And picked a few. I mean, they actually also referred to in the reference in the MDCG guidance on IT security. And so the first is a bit of an umbrella requirement, but it includes those small seeming 3 words like including information security, which plenty of auditors they are interpret as you need to do a risk management for data privacy and whole IT security and so on, in addition to the normal safety risk management. Then the next year, manufacturers shall set out minimum requirements concerning hardware, IT networks characteristics, and IT security measures, and so on. That basically covers the rest of the stack from the previous slide. So it may not be soup, but you still need to specify the environment in which your device is supposed to run, and inform people about what they need to run it. And either, I mean, if you operate the backend yourself, I mean, then it's obviously a little more straightforward. But if you provide others like hospitals with your device, then you also need to tell them, yeah, what they need to have in place for that. And obviously those need to be monitored. Like if you get feedback or learn that a certain operating system or whatever it runs on is not safe anymore, then you also need to update those requirements. So it's not soup, but you still have kind of the same work to do. Then continuing, so what to do? I mean, that's basically, I would guess, roughly 3 points. Like the one is like an initial check. So meaning like you add a library, what do you do when you add that? Then the second is like, or the point 2 and 3 are the kind of ongoing ones, but the one is more like, let's say the one is about post-market surveillance, basically. So once a year or however you do it, you sit down and you analyze things in detail. But let's say you have IT security problem like with Log4j a while ago, and let's say you had your PMS the day before, then Log4j came, and then you wait 364 days until your next PMS. Maybe not the best idea ever. So meaning that second part is more about proactive monitoring, where you can kind of subscribe to something, use tools to kind of be notified about issues that you at least should consider reacting to. And then the third is more about a more strategic, more systematic review on what to do. But let's have a quick look on each of them. Just switch tabs. Yeah, so basically for initial check, typically happening pre-market. Let's say that kind of the first point would be like, yeah, it's about when you select your libraries or soups in general, probably want to use some defined criteria. May not have to be the most elaborate, but also not just be like, yeah, every developer, just please add whatever library you find first on Stack Overflow, may also not be the best idea. So having, let's say, a review process, which may just be baked into your normal code review. I mean, adding libraries is usually done via a pull request as well, like the same as other code. So why not just adding it to that? So meaning like when as part of the pull request, there's a library being added, then there's just a couple of additional questions to answer. And that probably already helps a lot to add libraries of a certain quality and yeah, not just random ones that you quickly find. Yeah. Yeah, either via pull requests in GitHub, or if you have some more fancy tool where you organize your the soups or libraries that you have in a more internal system, obviously, then like instead of npm, for example, then that would have its own review process. This kind of software bill of material, kind of one of the newer terms in this field. I mean, earlier from the one of the results from the pre-record sessions was mentioned that like as much as possible should be automated. This is definitely one of those topics. Like the list of libraries, I mean, you have, for Node.js, it's in a package.json, and basically any other language has that. So at least libraries you have written somewhere. So, and then whatever list someone else wants to see, ideally that should be auto-generated, because otherwise it won't get done, and it won't get kept up to date. And like having like, I mean, I've never really seen any value in managing manual lists with the exact versions of libraries. Like that also usually gets outdated the second it got created. And yeah, regarding the topic of what about dependencies of dependencies, well, I hope you're not keeping lists of the manual lists of those either, but I guess where they become mostly relevant is when it comes to vulnerabilities, but again, should be automated. So like having some tool like Dependabot or what, I mean, there are plenty of tools around that kind of have the package.json or whatever file there is, and scan through that and scan through the dependencies of the different libraries. And that I think should, at least for low risk devices, work fairly well. And for high risk devices, there's hopefully not that long of a list of dependencies. So I guess so that should help here.
Awesome. Just for the time, we have about 5 more minutes.
Okay, yeah, should be not that much longer. Yeah, then this ongoing check, like this about detecting vulnerabilities where you shouldn't or don't want to wait for post-market surveillance, but have like some automated system, like some kind of tool or service running that informs you about that. I mean, ideally, maybe even creating pull requests directly as like some form of change request. And yeah, if you have tools that is not covered by that, should be subscribed to any newsletter, to any form of like source for updates. Like when you use that kind of a database or Python or basically the other parts that are not in the package.json or similar file, like those you should also still have a source for updates that you can react to. So that is this kind of active monitoring part, which I think is pretty important. And then the third part, which, so one more word to the second. So the second is more like, okay, there's a bug somewhere, you need to fix it. But now let's imagine there's a library where you had lots of bugs throughout the year. And maybe you at some point realize, no, this is so annoying, we have to find a new library. But you may just not if it's not that clear, you may not think about it that much. So once a year as part of post-market surveillance, I would typically recommend, at least for like 2A devices or with a bit higher risk profile, to do a more systematic review where you go through like the different critical vulnerabilities or findings from throughout the year and see whether you want to replace some of the libraries, or whether there are any issues with some of the services you use, or whatnot. So while the kind of this continuous ongoing throughout the year is more for reacting in the moment, this is more to make a more strategic decisions to see whether you can reduce your workload and attack surface in the future. Then as I was wondering, like, what to actually give something a bit more actionable. Maybe it's maybe not the right word for here, but maybe some takeaway from the presentation. So I think like looking at, so what are criteria to decide how deep or how extensive soup management and other management of other software that is somehow associated, or even hardware that is associated, should be done. I think the first is like risk class of device. If you make software for like surgery robots, or software that decides over fairly critical decisions, obviously you want to do a lot more and want to maybe even make give specifications on what other services can run on the same machine versus not. While if it's a low risk device, it may not matter much. Okay, and then results from safety and security risk management. Is it deployed internally? So basically, is it the same people who develop the software that also run it, versus is it deployed by other people? And then also region like US versus EU. So like the examples here were more about EU, but if there are US related questions, I think we can have a look at that during the questions or the discussion later. Yeah, there was a question.
Yeah, can I ask a question? So you're talking about the risk class of the device, but is it also related to the IEC 62304 risk class A, B, or C?
Yes, that would definitely also be a part of it. I mean, the IEC 62304 has like some really specific requirements that you need to do depending on the software safety class. Like, I mean, A is fairly straightforward. B wants you to do kind of a few more things. Yeah, that's correct.
Yeah. Okay. Thanks.
Sure, good question. Any other? I mean, that's basically it. So, so yeah, in the end, I think this point with the risk management was is in the end like one of the more critical points, like to see like what of the software do you need to monitor to what extent, and like let's say when it's about preventing any backdoors in compromised libraries that you may have scored via some npm library. Like if you happen to have some egress control on your servers, then it may not matter that much because they may not be able to call home anyways. So meaning like it's like this, I mean, risk management is kind of always the answer in regulatory, but it's the same here, basically.
So we start with 6 questions or 5 questions that we've gotten beforehand. And we want to go through these questions first. And after that, we open the questions up to the people that are here, questions that come up. I saw that, for example, already cybersecurity has come up. And you can enter these questions by clicking on the triangle, square, circle button and then going to Q&A. And there you, if you're right, you can see a plus ask question. So please use that functionality. And then we can go ahead to the first question that was submitted beforehand. And that is, what is the difference between the EU MDR and the USA FDA in terms of soup management? And I'm curious who would like to answer that one.
I can go first. At least I have some, the FDA experience because we launch our products in the US first. The FDA doesn't use the term soup. The only term that I really know is they use off the shelf. So you take, but you could consider like a library that you use when you're writing software, also something that you take off the shelf. It's just a digital one. But they are very, like they have a draft or they have a guidance where they are very specific on the types of information that they want you to provide. So you need to provide what's the version, who's the manufacturer, or who is maintaining this, give us a description, what do you intend to use it for, is it appropriate for that use, do you need to validate it, yes or no, is there an issue tracker? Like they have a whole list that you need to provide, and I presume if you don't provide this information, you're just giving them an excuse to reject your submission outright. I think the EU is more high level, that they more in line with their other regulations. Give a couple of guidelines that you need to follow that are all very sensible, but they are much less prescriptive about what you need to do, which I think is why we're all here, because it's unclear to everyone what is sufficient in order to meet those requirements.
So for question number 2, we have, why do we do soup management at all? What kind of incidents triggered the regulation? Does any of you know this? It's a very daring question.
Stefan, you want to say something?
Okay. Well, I could say that, I mean, if you include components that you're not sure of how they function, you can definitely end up in trouble. I'd say it's not more difficult than that.
So what I found like a very interesting read is this Therac 25 paper, which might maybe some of you know, with this radiotherapy machine, which killed a couple of people. And I think one of the issues they had with it is they used some like micro switches to set up the table, which didn't work as accurately as they expected them to. So yeah, my assumption is that this is basically the translation of supplier validation to software components.
Yeah. Thank you for that addition, Jeffrey.
But I mean,
I hope,
why we need
ahead.
it is pretty clear. I think is like, especially we were briefly talking about it in our breakout room. If you're a company, you don't even have a quality system, and you're making a device, you may be updating all your dependencies whenever you want. There's just a complete lack of control. And and it may fly under the radar because it's not very visible to say your quality regulatory person to make sure that the developers are not changing these things whenever they want. So having some kind of management in place for this all seems very sensible to me.
Yeah.
And I'm sure there are legions of examples where it has led to adverse events where, well, they chose to blame it on the soup rather than on poor integration of that soup into your own device.
It's never just soup, eh? It's you also have your own responsibility in incorporating the soup. That's a very great point. To me, it's also the answer is in the word dependency. You have a liability there, and if you don't know what's going on, you're you have a hole.
Go ahead, Oliver.
I think one interesting thing for me is like that possibly like the intent and the implementation of this aspect in this regulation also is like completely separate and very illogical, right? Because like the initial intent probably was, okay, there was like some harm done to patients because like software crashed, because like in the end maybe a soup component crashed, and then regulators probably thought, yeah, it's a very useful idea for people to like document their soup and their soup requirements without even like checking whether there's any causality between those two things. Like now we document all our soup requirements and all the soup stuff, and we just kind of assume that safer software comes out on the other side. But we simply actually don't know that. On the other hand, it's perfectly possible to document soup in a very compliant way and still ship like entirely crappy software which crashes because of your soup. So right now it's like an entire documentation effort which maybe was based on a useful intent 20 or 30 years ago, but right now the idea is pretty stupid in my opinion.
Yeah, and how would you change it to make it not completely stupid?
It's a very good question. I mean, it would have to be closer to reality and less abstract, right? Like it's very abstract right now. Right now, it's like, okay, you have like soup, and soup is like any sort of software out there. And if you use it, you have to define requirements and analyze risks. So that's like way too abstract. So for example, you would need to like update it to like the world we currently live in, where everyone is using like open source software, and that selection maybe is based on how popular packages are and how well tested they are. So I would need to come up with like a realistic measurement of, okay, if I use a popular open source package, and I don't know, there are great examples for that, like Django or Flask or whatever in Python, or Ruby on Rails if you're coding Ruby, or any sort of like Node.js popular package. Whereas actually those are often pretty crappy. But if you're using like one of the popular package, in my opinion, there's simply nothing you really would need to do, because that software tends to be way more bulletproof than the typical free or shareware Windows 63 or 4 was written. So like if you're using like these popular packages, then in my opinion, right now you wouldn't need to do very much. It gets like very dangerous if you use like this random GitHub library you find which has like 20 stars and is like maintained by one person. That in my opinion is like on a different level. So take those things into account and like take more modern tooling into account. Like you have like Pascal mentioned, you have tools like Dependabot, which automatically scan your code for what essentially is soup and notify you if there are like security problems in one of those, and you would need to like update them, that sort of things. It would be like way more specific. Right now, like nowadays, none of these aspects is considered in the regulation, because also auditors generally often don't know these tools because they're, I don't know, 100 years old, and the last time they coded was like on a COBOL mainframe or so. So, and it would need to be like way more up to date than that. But those are just like a few ideas.
Yeah, great suggestions. Stefan, did you have to add something to that?
Just one thought. I mean, popular packages or popular soups could actually be a bigger risk since they're used by more people, and then there are more people exploiting vulnerabilities in them. So they could be a bigger risk, at least from an information security perspective.
I would strongly disagree. I mean, your point is generally, like, an aspect of your point is correct. There's a higher incentive to find a vulnerability in an open source package, which is widely used, obviously, because then I can like attack a larger, higher number of companies or whoever is using them. But on the technical level, like if I look at
code I write versus code I can take from a popular open source library, I would say that code from the popular open source library is like 10 times, 100 times, or maybe even 1,000 times more stable if you go by like bugs per line of code, for example. And if I only take that measure, and that measure personally I think would be way more important, then I should always try to like choose that sort of code, which is also usually much more well tested than mine.
They typically also expect you to, for example, have a find the bug tracker and inspect it regularly if there's any bugs that are impacting you. But like say you're making a cloud application, if you've done your network segregation well, all these services that are running in your cloud are like not connected to the outside internet, and that there's a CVE in one of those libraries. Yes, it's on the internet, but it's, you know, there's just, what's the attack vector that they can actually pull that off on your machine is oftentimes just very remote. So even, you know, the example that was just given, yes, it may be or it may be targeted, but then it's, you know, how likely is it that they can pull off that attack in your infrastructure is not typically as easy. I think I agree with Oliver, like that we all need to chill out to some extent, but it probably relies on having great taste in, like, I know I should only use libraries that are well vetted, stable, have a lot of maintainers, and they have a great track record. You know, if you're a small startup, you just hired someone who is not as experienced or doesn't have this this great taste, I can see how it's hard for others to know, will this person also make the right choices? I haven't figured out how to like change myself into ChatGPT yet, so we can like farm myself out to others, unfortunately.
Yeah. And with that, I want to move on to the next question, because we also want to take audience questions. So maybe for Stefan, what is the least I have to do to manage soup in a compliant way for a low-risk device in the EU?
Oh, that's a question for me. It's literally fill out this template, which is for free on our website. Full stop. It's I don't know. Like you're currently sharing the screen. I can also share my screen briefly to like just show it. It's literally super simple, and like you can be done in an afternoon or even less. Like it's like you find our website here, soup list template. I won't go through our website. You can download this in all sorts of like forms, but it boils down to this table. And if you have this table, then you're done. So you have like a table. It has like IDs. Each soup can be like identified. For example, you have React Native here. You list the programming language, version, link to the website. When you like verified it, risk level, where you like can define your own risk levels at the top, like low, medium, or high in this case. Requirements as a bullet point list, and verification reasoning is our reasoning here, which you can copy paste for literally every entry, which is like a popular open source library, just copy paste it. And this resembles, in my opinion, the minimum which will pass. If you have an auditor who doesn't understand software very well, which is quite likely, then they will just check for the existence of the soup list and that there are some entries and that you essentially have most of these headings, and then you're done.
Great tool. Pascal, do you have a comment on that?
Yeah, I mean, I was just wondering, because I mean, it looks like still quite some effort, especially in keeping that up to date. Like with, if you have a bit of a longer list with keeping those versions up to date, I mean, wouldn't the minimum work actually even be more like having the package.json or whatever that file where you write down your dependencies for the specific language you're using be like the minimum work to do? I mean, for package.json, you still need to add the manufacturer if that exists for a specific one, but to be compliant with the 62304, you need the designator for the library, which is the name. You need the version, which you hopefully specify in there anyways. So you only need to add the manufacturer as a comment, and you're basically good.
So that depends on your 62304 category, right? So everything you said is true.
I mean,
like,
so but we're talking about low
class
risk.
A. Yes. So for class A, that's true. You can simply use a dependency list and claim that, yes, that lists all your dependencies plus their versions, and you're done. That's very true. Yeah. For class B, essentially it's my implementation. For class B, you need like the requirements plus the risk assessment. And probably that's it. Yeah, but like those two additional things.
Right. Just wanted to lower the bar a little bit further. So
Yeah.
So it's all in the hands of the listener to interpret and to make the choice.
I don't have the list of EU requirements at hand, but I also believe they want you to like think about the life cycle. So at least one thing I find is important is that you show that you have control over your design. And if you do an update, like don't change your soup just because you feel like it. It typically should be like also to avoid the paperwork, like only update it if there's a bug that is like hurting you, causing problems for your device, or if there's a security risk that was found and that might impact you. Otherwise, like, well, typically avoid updating your soup, or make sure that you do all the work and not just update the software and then leave your paperwork out of sync with what you're doing. So I do think it's important that folks are able to like demonstrate that they have this level of control over their soup.
Yeah, great addition. Thank you. So then I want to move on to question number 4. And I think this kind of links to the nice image that Pascal already shared. And that is there a standard for what is considered soup? Are browsers soup? Can they be considered soup? Are all dependency soups? And then we have the dependencies of dependencies discussion. But I want to leave that a little bit for now. So maybe Stefan, you can share how you see that in your company.
All right, so we started off at a very low level with our soup list with all the different packages that we were including. But then we decided that this list, those are soups or components where we actually see the source code and have great control over and can test that as part of our software. So we moved our soup list up to a higher level, like some of the SaaS services that we use for secure login, for video conferencing. So actually our soup list is quite high level, and that worked well with our auditor.
Okay. So it is a little bit of sometimes I have this approach in regulatory that I do a little bit the minimum and then see if it's okay.
Yeah.
And in this case, it's okay. So that's great. Jeffrey, did you have something to add there?
Yes, so just to clarify, so what you're saying is basically everything you integrate in your product, then you just don't treat the soup at all anymore. You still have it on the list.
No, they are not. I mean, all the components where we can look at the source code, those are not in the soup list anymore.
So you just say basically it's like code you wrote because you can see it and you can fix it when something happens.
Yes.
Oh, that's an interesting approach.
Yeah, and we were open with that with our auditor.
Cool, thanks.
And you have the certificate, right? So you made it.
Yeah.
Pascal, did you have something to add there?
Yeah, but just quickly commenting on the last remark, like in the 6304 quite clearly says that software that was not developed according to a life cycle, like a soup. So meaning like even if you have access to the code, if it was not developed according to a software development process or someone else's that is compliant with medical device regulatory rules, like should be soup. So I mean, obviously yours was passing, but just bring up that may not be the case for other auditors.
Yes, but still there is the debate on the software item. What would that be? Is that lines of code, or is that a something bigger than just lines of code?
True. I mean, whatever you decide, right, or define.
Yes. Yeah. So I mean, that was part of our reasoning as well. That software item, no, just lines of code that we are including is not an item. It's not a software item.
To me, I like the approach. I mean, it makes more sense fundamentally to me. unless you're at the very high risk class where you need to be very in control of every single, because you need to have all the requirements, all the test cases, etc. Then it would feel like you need more scrutiny. But for low risk, makes sense.
So this question, of course, touches upon various things. There's our browser soup. Jouke asked is AWS soup. I mean, they are definitely of unknown provenance, as Pascal points out. So in that regard, I would say yes. It's also, I guess, a little bit confusing that there are various terms to describe it, whether it's soup or off the shelf. Go ahead, Vincent, if you want to add something to that.
Yeah, I have quite a strong opinion that things like the Amazon Web Services is part of the IT environment which is required to run your device. At least you need to document such requirements. It's in one of the GSPRs, but you don't incorporate AWS or Google Cloud or whatever into your device. And I mean, yeah, it's in the definition of soup. It's something that you incorporate into your device.
So of course, AWS means different things to different people. So it's the thing that runs your infrastructure, but for someone else, it could also mean it's just your database. And if I use a hosted database, what's the difference if I run MySQL or Postgres myself? Is it then like, why if I use AWS's, it's not integrated? If it contains the same bugs as mainstream Postgres, it can, bring my app down wherever it's running. So I think it's just a gray area.
Yeah, you still need to control it and monitor it, but it's not part of soup. But
I think, so
like I said, it's an opinion.
Okay, yeah. So
it's a very interesting
point. Curious what the group thinks. So maybe let's do a little poll with the thumbs up and the thumbs down. So if you think that AWS is soup, please give a thumbs up. And if it's not soup, give a thumbs down.
I mean, it's kind of like it's a more like differentiated discussion, right? Like it depends what you use of AWS. If you use AWS, like you could use like DigitalOcean or Hetzner, like the typical server providers, or any web host that you could use for like providing it with a server, then yes, it's not soup because it's simply your infrastructure provider. So it has to be controlled as like your supplier essentially. So it falls under supplier evaluation and might even be a critical supplier. But now AWS differs, like cloud providers do, from these hosting providers by also providing kind of like almost like software as a service. So you could like use hosted machine learning software, which goes even further than Ivor's example of a hosted database, where it would really integrate AWS software to some degree via an API into your software. So you would maybe say, okay, we're using a voice recognition API from AWS. So I don't know, patients speak into their phone and that gets sent to some AWS service you're using, and it gets transcribed into text, and that goes into as input into your medical device. So now I think the border becomes way more blurry. Now suddenly AWS is getting very, very close to soup, in my opinion. Now, would I document AWS as soup now? Probably I still wouldn't, but simply because it's too much hassle, and AWS would already be in my supplier list, and I would think that's fine, and the auditor won't understand it anyway.
I really like this way of thinking. I'm on the same page. I would struggle with having voice recognition of AWS in the application and then putting a version on it, and also being in control of the release cycle, because you're completely not, right? They upgrade whenever they want to. So
exactly.
But I mean, so you're correct that it's hard or impossible, but then just say NA or explain that it's, the service does not provide a version. I don't see how it absolves you of determining what the risk for your device is of this thing, or, some of the other questions are still answerable. Why, just literally just give the answer that you're giving here should be fine, I think. I also wanted to respond to at our company in terms of like how granular do we make it. Like we use Python and JavaScript. If we have a Python version, everything we list as a direct dependency gets included in our analysis. So as when it comes to the dependencies of dependencies, yeah, and that's where we like stop the discussion. It's already like I have it open at the moment. it's like 82 items, or I think even more. It's already long enough. And when it comes to like verification to tie it into the software architecture and software items discussion, I can like we're integrating it into our software. We are testing our software, and that should be proof that the soup is also like functioning as we're the requirements that we put on our device. It's the soup is helping us accomplish that. And if there is a risk that, I mean, when we're talking about a database or something like Redis, where it has a risk of bringing stuff down, well, then I need to make perhaps a design risk regarding that to cover that separately. But I wouldn't necessarily go much deeper than that.
It ties in with the last question of the send-in questions, which is, can soup just be tested as medical device software? And
I would say definitely. There's separately, like, so if some of your soup is also a tool, and you have, maybe you're using some features in order, your device relies on certain features where it needs to be installed properly, and those are things that are not a requirement for your device, and your tool validation process would need to ensure that it's capable of meeting those requirements that you have for that tool. But I feel that those are two separate discussions, really. Go ahead, Anja.
Yeah, I just want to say, maybe you can have an analogy of a soup is a part of, if you would have a hardware device, or any kind of physical device or tangible device, it's not enough to test the final device. You also need to know where the components come from, and that the manufacturing of the different component goes well in that way. So in terms of validation of the components of the hardware device, coming from a more kind of tangible medical device regulatory field, my analogy is the soup is the same thing as a building block or a component on a hardware device. You have to know where it comes from. You have to qualify the the manufacturer. You have to qualify the component to make sure that the overall medical device is compliant. So maybe that's an analogy which is helping to think about the same way in soup.
Yeah, and if I can add something, I think that the tool validation, in fact, is a bit similar to the process validation in hardware production. So anything that you're using in your process needs to be validated as such. So, and that's also one thing that sometimes soup may blend in your product, but anything you use to build it will have to be validated as a kind of tool. So that's what I think.
I think where we typically draw or make a distinction is like if you download a binary, like an executable or something for a database, or for something that you use, I consider it more like a tool. But when it's like literally modules of Python, for example, that end up in the actual device like that, I just treat it slightly differently. So I wouldn't do a tool validation for those Python packages that way, unless it's like, again, something that does my machine learning, but it provides like an application type interface, and it does everything for us.
Yeah, and I think the analogy, and that's what I wanted to say, with hardware production, which I'm also familiar with, this can be very good. So your process validation, you have your incoming inspection of components, you have your component release. Anything you use in your hardware, you have to look at and release it as a component or part. And you can make quite a good analogy, I think, with hardware production. So yeah, that's helping me a lot of the time. Yeah.
That was my line.
Still, I wouldn't draw the analogy with hardware too far, because with hardware components, you cannot look inside them and verify that everything inside is per specification. Then you're including a black box. But with software, you can inspect and test the source code yourself.
But
that depends on the hardware.
Hardware, yeah, I would think.
But also related with what you were saying for the hardware, you want to know where the component is coming from. Well, then it would not be soup. It's unknown provenance, and we actually don't know what is happening or how it came to be.
But actually, this is something that in hardware medical devices is part of the risk-based approach. If it's a component that is designed to be included in a medical device because it's certified against some IEC 60601 standard, then you need to apply less control than when you buy some hardware component that was never designed to be part of a medical device.
But you also have something like critical components. So when it's not critical, you could buy it on the Chinese stock market, I don't know, and include it in your products. But when it's critical, you have to have a lot of extra controls. And with soup or software, it may be a similar thing. Now, when it has a critical function in like your medical module part of your device, of your software, I think it's more critical than when it's part of another module, non-medical kind of module of your software.
And I don't remember actually if this was my question, but it's kind of anyway in line with the main question that I have on my there. But when I define the requirements for my device, and I will define all the requirements that I think are critical, and it doesn't really matter if they are going to be implemented by soup or not, I'm going to test them to the same extent. And that's where I sometimes struggle. Do I need to be explicit in requirements for the soup? It's in my requirements for the device if it's something that is specifically relevant for it.
Yeah, that's a great point. And I want to round off this discussion here. And we have one submitted question from Jeffrey. So if you want to ask it, go ahead.
Yeah, we quickly talked about it earlier, this requirement that you should check the bug trackers of the soup you include. I found that interesting because we tried it once, but it seemed completely impossible because there are like hundreds of open issues in each one of these libraries. So I was wondering if like anybody is doing this in some sensible way.
I think like in my experience, it's like it depends on the library you're looking at. Like if you're looking at like a large library again, like Django, Rails, or PyTorch or whatever, then yes, the issue trackers are pretty much full and there's no way you can go through all of those. But those also tend to have like some sort of like known issues pages or so. If you like skim like the release pages, for example, where they like have the update notes for each release. So I would just read those, because usually those large packages, they don't stay published for a long time if they have like critical vulnerabilities. So that's how we do it for like large packages. And then for small packages, the issue lists actually tend to be readable. If it's like, usually there are maybe like 20 or 50 open issues. And I mean, regardless of regulatory stuff, I actually sometimes skim those when I take a library and I just skim it quickly to see if there's any huge bug which I'm missing. If it's just like 2 or 3 pages on GitHub, I can like skim it quickly and then you're also done. So that should cover most of the use cases actually.
Okay.
We have a vulnerability tracker that looks at CVEs, and we print that out in our repository. So every time in our CI/CD we check it, so we know every time someone commits something if there's a CVE open.
Yep.
And then we look at it and say, hey, we're going to upgrade the library, or we're not going to upgrade the library. Works pretty well. Yeah,
for cybersecurity we also do it, and it works well. But for like normal functional bugs, everywhere I looked at it was huge lists, but
it's difficult.
I mean, maybe one more example, like one project I was working on was like high risk for software safety class C, and so you kind of wanted to make sure that it works the way you want to. But it was fairly limited. I mean, based on Python, and the main module or library used was SciPy, if I remember correctly. But it was like limited to like a quite distinct number of functions. So we basically just searched for all those functions and looked through the bugs and double checked that they don't interfere with what we were doing. So that I mean, it was a little bit of work, but it worked kind of okay-ish. So overall, the bug tracker had like a lot of bug reports, but when you reduced it down to the relevant ones, it was maybe 30 or so.
And then you also have to document that you did that analysis, of course. All right, I think we are exactly on time, so we have 5 minutes for 5 minutes to 10. That leaves me 5 minutes to round up. I'm not going to use those 5 minutes, probably 30 seconds. Thank you all for your time, expertise today. It was great. I will post the videos in about 2 weeks. And please, if you would like to help with scouting for people for the next Meetup group, let me know. Either put it in the chat here or just on Slack. I would like that a lot because you can really help us. Because to me, it was pretty stressful to find people this time. And I would like to have that more distributed next time. So once again, thank you to all of the speakers. Thank you also, Emma, for hosting tonight. Thank you, Oliver, Ivo, Stefan, and Pascal. You were amazing. We are planning the next one for the 28th of June, so in 1.5 months. And it looks like internal and external audits or startup culture is our hot topics. So stay tuned. And thank you.